The Bureau of Met provide an excellent service called GIS to Web. This is a range of web mapping services that we can incorporate into our GIS systems. The very important cyclone track information, the current level that it's at, and also the anticipated path that it's going to take. A feed from the Himawari satellite, and then a range of observational data sets, including warnings, surface observations, and the important wind direction and speed of this particular cyclone. What I want to look at is how we can tap into this very important feed that's continuously changing and access it within the Microsoft Fabric environment and do some spatial analytics on it. Why are we doing this in Fabric? Because Fabric can scale quite quickly. It allows us to continuously, repeatedly ask questions and actually get the answers quite quickly as that cyclone track is changing. First off is actually tapping into the GIS to Web WFS endpoint, pulling it into a data frame, filtering it down just to the Alfred cyclone. This gives us the different cones for 72 hours and 122 hours. Then we're going to essentially just plot that out, see those two different cones for the 72 hour and 120 hour paths. Then we want to understand, well, how many address points are in those paths. This could also be buildings or other data sets that you might have. I'm pulling this from a Azure blob container, and then really just this bit of code here is essentially just doing a spatial join, selecting how many of those address points are within each of those different cones, and then outputting that. And we can see here the results for 72 hours, 122 hours, and also the resulting, just a quick plot within the notebook to visually understand what does that look like. And it's quite a lot of address points there. Same thing for roads. We can pluck out the national roads from the Digital Atlas of Australia and use that in our analysis to do a very similar type of spatial join. In this case, just counting and also understanding the length of roads that's within each of those different tracks. Then we can persist that into a lakehouse for reporting purposes. Essentially, what this does is just wrap that up and probably could be optimized a bit there. So then we can use that in, this is a very simple Power BI report, but of course you could have quite elaborate Power BI reports that continuously change as that scheduled notebook keeps triggering to be run every time the Bureau of Met service changes. We've also going to tap into some live Waze incident data. We've got that being ingested from another process altogether. Pull that in. Again, a fairly similar spatial join, doing a ST intersects this time, and then persisting that again into our Fabric data lake. So we can again use that in Power BI, but in this case, we're also pushing it into ArcGIS so that we can actually understand what is the Waze activity in each of those cones and what sort of types are being pulled out. And this could be particularly interesting, when the different types of reports around flood reports or cars stopped on the side of the road. It's just another data point to really understand what's happening during an event such as a cyclone.